Welcome back to another episode of my Implicit Differentiation series. This lesson I'll be focusing on graphs, not really anything solving, and not going into too much detail with the graph, just showing you the graph of a function, then implicitly deriving it. Okay? So, here we have, I'm going to be using a typical book. If you've watched my other ones, it's James Stewart Calculus, metric version. It's done by, you can't probably read it, but it's Cengage Learning or Cengage Learning. I'm probably shredding the name. I'm good at maths, not words. Okay, so here we have, that's what we're going to be solving today. We're going to be solving this function to be able to find the slope at any point on this graph. Okay? It's a bit of a funky one. Lines going everywhere, but let's get right to it. I'm not going to redraw it because I've tried. It's not good. Okay, so number 1, so sine x multiplied by y equals sine x plus sine y. So we have we're going to find the derivative. I'm just going to use quotation marks because it just means it, directly below. If I keep rewriting these things out constantly in all these videos, I'll be here forever. Okay, so we have find the derivative of this and the derivative of this. This is going to be pretty easy. This, we're going to need the product rule. So this one we'll call u, and this one we'll call v. Okay? So the first side will be the derivative of the outside, which will be the derivative of sine, which is just cos of xy, and then we multiply that by the derivative of the inside, which will be u dash v plus u v dash. Now this side, you have sine x, the derivative of sine x is cos x, multiplied by the derivative of the inside, derivative of x with respect to x, plus derivative of sine y is going to be cosine of y, multiplied by the derivative of y with respect to x, because that's the derivative of the inside. Okay, now for this side, cos of xy, if u is x, then u dash would be derivative of x with respect to x, multiplied by v, which is y, plus u, which is x, multiplied by the derivative of v, derivative of y is, as it sounds, the derivative of y, equals cos x, multiplied by 1, you just leave it, plus cos y, multiplied by dy dx. Okay, so I'm going to have to expand this side out. That's going to look like cos xy multiplied by y, because it's going to be multiplied by 1 multiplied by y, so it's just the y, plus we're going to have the derivative of y with respect to x multiplied by x cos xy. That's going to equal all this stuff above. Okay. Next step, to rearrange to have all the dy dx on one side and all the others on the other. So we're going to keep the y cos xy on this side, and we're going to subtract by cos x to bring it on this side, plus equals, sorry, it's going to be cos y multiplied by dy dx minus this, so we can subtract it, so we can bring it on this side, dy dx x cos xy. Okay, now that we have this, we'll expand it out. This side will stay the same, but this side will factor out the dy dx to get it on its own. And it'll have cos of y minus x cos of xy. And now what we're going to do is divide both sides by this, and that'll cancel that out on this side, leaving us with just the derivative. And on this side we'll have y cos xy minus cos x over cos over this, which would be cos of y minus x cos xy. And that there is the derivative. So if we have an x and a y value, we can therefore find the slope anywhere on that. Really ridiculous. That on this. That's my professional drawing of that graph. Anyway, thanks for watching these videos. If they're any help to you, please comment or like, and I hope you have a good day.